In this video, we are going to talk about something called the constant of proportionality. It is on page 14, and make sure it says student handout 1, and it looks like this. Okay. All right, so two quantities are proportional if the ratio between those quantities is equivalent. So that's just kind of like a space to hold that information. We will get into exactly what that looks like. So in this example, it says Mario travels 180 miles in 2.5 hours. If Mario travels at the same rate, how far can he travel in 5 hours? So we can fill in our table. Okay. So in 2.5 hours, he travels 180 miles. There are several different ways we can go about filling out this table. One way we can do it is that I know that 2.5 times 2 is 5. Okay. So if I did this number times 2, it gives me this blank spot. So that would work. So 180, try again, is 360. So he would go 360 miles in 5 hours, which answers this question. Okay. Another way to do it, I think an easier way to do it would be to find the unit rate. Which is the miles per hour. So in one of these examples, I'm going to take the number of miles, 180, divided by the number of hours, 2.5, means that he goes 72 miles per hour. So if he goes 72 miles in 1 hour, I can use that to multiply. So 7.5 hours times 72 miles per hour will give me this blank. Is 540 miles. Okay. 10 times 72 miles per hour will give me this blank. 720 miles in 10 hours. Same thing, 12.5 times 72 gives me this blank. He goes 900 miles in 12.5 hours. Okay. So since he's going at that same rate, I can multiply by the same thing over and over and over, right? That constant unit rate, we can also call it, this is called the constant of proportionality. Okay. And it is the value of that ratio, dropping stuff over here, okay, between two proportional quantities. So if they are still related, if they are describing the same situation, then it is proportional. So let's add to the side that we can also think of this as the constant unit rate. Right, 72 miles per hour. In each of these instances, Mario is driving 72 miles per hour just for a different length of time. All right, so this constant of proportionality, this constant unit rate, we note with the letter K that we're using the letter C to mean something else. And it comes from taking the y value divided by the x value. So in a table or graph, it will tell us what y and x are, and then we just do the division. Okay, something else to note is that there is an equation that we can also use, that the y value comes from taking that unit rate k times the x value. So add that below, that's going to be really important. They kind of all go together. All right, so it says, examine the table below, describe patterns that are true. So the number of feet is x, the number of inches is y, so each time I'm going to take y divided by x and see what we get. So right now my y value is 12 divided by the x value that goes with it is 1. You're going to have to write small. 12 divided by 1 is 12. All right, next one. The y value is 24 divided by the x value that goes with it is 2. 24 divided by 2 is 12. And then I can keep doing that. 36 divided by 3 is 12. 48 divided by 4 is 12. 60 divided by 5 is 12. Okay. So, pause for a second and think about this question. What do we notice? Hopefully you're noticing that that unit rate is 12 every time. That constant of proportionality is 12 every single time. That's what makes it constant, right? Constant means ongoing. So how do you know that the number of feet is proportional to the number of inches? It has a constant unit rate. So if they have that same unit rate over and over, it's going to be proportional. If they don't, it's not proportional. So it says, using x, the number of feet, how would you find y, the number of inches? All this is saying is, hey, we have this relationship. They are related by the number 12 each time. How do I get from feet to inches using this number 12? Well, it's multiplying, right? 2 times 12 is 24. 3 times 12 is 36. 4 times 12 is 48. So each time you're multiplying the number of feet by 12. All right, flip to the next page. All right, up here it kind of has that little reminder. So y is the y value from the table. K represents the constant of proportionality. And x represents the x value from the table. Okay. And then also let's add to the top that our constant of proportionality, that number that they're related by, comes from taking the y value divided by the x value. All right, we've got a couple more examples. While training for a marathon, Keith's watch reported how many calories he burned at each mile marker, and that data is shown in this table. So you can see that after 1 mile, he burned 117 calories. 2 miles, 234. You could read the rest of the table. And we want to know, is the number of calories proportional to the number of miles, and explain how we know. So the number of miles is our x value, and calories is y. All All right, so to figure out for each one, I'm going to take y divided by x and see if I get the same thing for every one. If I do, it's proportional. So y divided by x. So I'm going to take 117 divided by 1 is 117. I'm going to take my y value divided by my x value, so 234 divided by 2 is 117. Even if you think you are noticing a pattern, you really should check every single point just to make sure, because what if the last one doesn't apply? So check every single one just to double check, okay? So my y value is 351 divided by the x value that goes with it, 3, is 117. My y value, 468, divided by the x value that goes with it is 117. And then 585 divided by 5 is 117. Okay, so this is proportional. So, all right, with this color. Yes, because he burns 117 calories for every mile he runs. We'll just say for every mile so that we got a chance of fitting it on the page. All right, so it says, the next day Keith ran 7.5 miles. How many calories did he burn? Well, we can use that, right? I could extend my table. 7.5. So if I take the number of miles times that unit rate, it's going to give me the number of calories he burned. So we're going to do 7.5 times 117. It's going to be 877.5 calories. All right, so what is the constant of proportionality? It's 117, right? It's this number that they are linked by every single time. When I took the y value divided by the x value and I got the same thing every time, that is the constant of proportionality. So an equation, we're going to go back to what we said on this page. This equation, that y equals kx, all I have to do to write the equation is to replace k with that constant of proportionality. So y equals 117x. So, right? So the number of calories burned, y, comes from 117 times x, which is the number of miles. So this is the equation we can use to describe that relationship, right? In math, we're just letting letters represent these words. The calories comes from 117 times the number of miles. Okay, I'm going to do one of these examples with you, and then I'm going to have you try the other two on your own. So this first one, taking y divided by x. X is the cups of oil and y is the cups of water. Let's label our tables real quick before we get too far in it. Just to help you out there. So each time I'm going to take the y value, so 6, divided by 1.5. Is 4. Then I'm going to do 16, the y value, divided by the x value, 4. 16 divided by 4 is 4. Then I'm going to take my y value, 22, divided by the x value that goes with it, 5.5. There you go, now I can see the calculator. Is 4. The last one, my y value is 30, divided by the x value that goes with it, 7.5, is 4. So that constant of proportionality, k, equals 4. All right, I would like you to go ahead, pause the video, try the other two on your own, then come and check back in. Okay, so now that you've paused, we're gonna go through and check. So each time I'm gonna take the y value, so 3 divided by the x value is 2, is 1.5. The y value 6 divided by the x that goes with it, 4, is 1.5. 9 divided by 6 is 1.5. 12 divided by 8 is 1.5. So this is a proportional table because that unit rate was the same for every point in the table, and my constant of proportionality is 1.5. All right, same thing over here. I'm going to take the y value divided by the x value every time. 36 divided by 3 is 12. 60 divided by 5 is 12. 72 divided by 6 is 12. 96 divided by 8 is 12. So that unit rate is the same. This is the proportional table, and my constant of proportionality is 12.